Welcome back to the Introduction to Linked Data using Python course. Last time we went over search using Sparkle, and now we're going to get into JSONifying our linked data. So for this lesson, we are going to manually go through a process to represent the entities, the individuals that we're interested in, using collections and JSON documents. The lesson after this, we're going to use a much more streamlined and standardized approach using JSON LD processors, standard processors, in order to frame our documents. So this particular lesson is a bit more of a walkthrough of a harder way to do this, but in a way that hopefully is pedagogical and explains how one might manually go from triple data into JSON format. So specifically, what we're going to do here, so here's my little title for this, and we are going to make collections of JSON documents for the following things, for things that are of type, RDF type, Nobel Prize, Laureate Award, Laureate category, all of our institutions, that is, things that are in the object place of triples for which affiliation is the predicate, and countries, so objects of triples for which DBpedia ontology country is the predicate. So we're going to walk through some of this. I'll be pasting code blocks and walking through what they mean. So for this first thing, what we're going to do, I am mapping these classes according to the compact URI format given our RDF prefixing to what I'm just going to call collections of JSON documents, so lists, Python lists. And so this is just a mapping from one to the other, and I am going to create what I'm going to term a database. This is similar to how database access and the abstraction works for MongoDB, so it will be hopefully helpful to you, at least with the PyMongo driver. So essentially a database is a dictionary where by default each entry of the dictionary is in fact a collection, and we'll see how this plays out using the standard library default dict. So for each item of this class collection mapping, for class and collection in these items, we're going to prepare a query, Sparkle query, if you'll remember from last time, where we are going to get all of the subject, predicates, and objects where the subject is a member of this class. So in other words, it has a triple RDF type, but we can use A for Sparkle. And we're going to get all of the subject and predicate objects, all of the triples, all of the facts in the triple store, in our knowledge graph, which correspond to that subject, which is of this class. And we have our namespace so that we can initialize that there, and we're just going to print out, or we're not going to print out, so we're going to query this our named graph, our RDF graph, and for each row, we're going to deconstruct out that row, and we are going to say, okay, in our database, for the given collection, we're going to have a dictionary where each subject is a key there, and each predicate is sort of a key within that, and the value of that will be the object. So this is based on this kind of construction that we're able to do this. So I execute that, and the next thing that we're going to do, we'll inspect this at the end, but the next thing that we'll do is we'll prepare a query where we want to get all of these institutions and all the statements about institutions, where we're defining an institution as something that appears in the object place of any triple where the predicate is affiliation. And we are preparing that query and populating our institutions collection with all of those subject, predicate, and object pairs. So we've done all of these classes, these 4 classes. We've done institutions, and so now finally we have countries to do. And so how I've set that up is this this cell. So I'm setting up a set of individual countries. I'm preparing a query where I find triples where the predicate is country, and so I call that variable country, and I'm using the distinct modifier in Sparkle to find the distinct countries for which this is the case. So I should get some distinct countries here, and these are going to be rows with only one member. So when we get for row in executing the query, we just take the first element. There's only one element in the tuple of those rows. We can stringify it and add it to the set of individual countries. So we have that in Python. At this point, we can talk about birth countries. So not at the end of a DBO country statement, but there may be laureates that have a birthplace of somewhere, and that is considered a country. So these are also countries. We also want to consider them countries, even though they're not found through this particular triple pattern. And again, we do the similar thing. We add these to our set of individual countries. And so then what we do is we go ahead and iterate through our individual countries, and we prepare a query. And here we're using string formatting in order to put in the URI for the country, where we use this bracket notation to indicate in Sparkle that this is a URI. This is not to be considered an individual string or query, compact URI. And we're finding all of the triples for which that country, the URI for the country, is the subject, and we're getting all of that stuff out. So for each row in this query, we populate our countries collection, subject, predicate, and object. Okay, so we've got that. And then the next thing that we're going to do here, so this is where it gets a little hairy, because I'm not using JSON LD. So I'll walk over this briefly. This will be in the template as well. But what I'm doing is I am taking from Python JSON encoder. So how you get from a Python object to a JSON string. I am inheriting from that, and I'm essentially just changing it a little bit so that I can have this is instance thing overridden, so that I can override default Python type. So we'll see what that means in a bit. But I essentially copied this from the Python source code and just changed a couple of things. So this is mostly the thing that I changed. I'm not using the underlying C library, and I'm avoiding some custom thing that's not necessary. So mostly it's about setting this is instance, that check, so that then what I can do is I can create a custom object encoder. So that's what I named this class, which is a JSON encoder. And so normally you can make a JSON encoder and have your default function be what you mean. But I need this is instance override to say that if something overloads with a given type, so I think in RDFlib, one or both of these things are also considered strings, and so the JSON encoder won't pass it to the default because it'll say, I know how to do a string. But what it's saying is well, if it multiply inherits and it also happens to be a literal, then say it's false, and so go to this default. And so what I'm doing here, if it's a literal value, I'm outputting this dictionary, and then if there's a data type property on it, then I enter that into the dictionary, in language, etc. So I'm converting attributes to key value pairs, and I'm doing this bnode format, converting date times to string formatting, etc. And so after this happens, what I can do is I can take my database, my quote-unquote database, and I can dump it to a JSON string using this term encoder, and then load it back into default Python data structures, so that it's nothing about, it doesn't have RDFlib classes like literal or bnode. It's just going to be easily JSONable Python data structures, dictionaries, lists, strings, numbers, that sort of thing. Okay, JSON's not defined. That's fine. I thought I had imported it earlier in an earlier lesson. And so here, what we have, I'm going to go ahead and just save this to disk so that you have it and can inspect it at your leisure. And I can make sure to gzip it, so that's what will be presented. It's about 1/4 meg. And here we'll go ahead and see what's actually in this thing. So I'll just load it up from disk, and here we can see what we did, what all that work is. Although you can certainly look at this yourself, but here's one way to do it. So take, as we know, dictionary, the database has a dictionary API for access. So the keys are the collection names, and then the values is the collection. And so given a collection, each collection is a key value of an individual, so the ID of the individual, and a document. And so let's take the first 5 individuals of each collection and print these out. So we can see, for example, the collection of Nobel Prizes. Our first document has this ID, and here is the dictionary of key value pairs that correspond to the predicate object pairs of the triples for this subject. So this Nobel Prize of Literature 1901 has a category of literature, has a category order of this, has a laureate of this, a year of 1901, where this is a literal value, so it has a data type of integer, all this stuff. And so here are a few documents in the Nobel Prizes collection. Nobel Laureate, the Laureate Awards collection, we have this document that has all these predicate objects category, piece, laureate this, motivation. Here's the motivation, the value, and it has a language attribute, English. So laureate awards, and we did the first 5 of each of these collections. So here we go. Here's institutions. So this ID is URI of Yale University. So okay, uses DB ontology city, New Haven, etc. Institutions, and we have some countries. Okay, it looks like we did the countries thing incorrectly. I thought we may have done that incorrectly. Let me see if I can do that live. So I think what we did incorrectly here is we didn't actually bind this value country to anything. We sort of found these predicate objects, but we didn't really bind this to country. Let's see. One thing we can do here, I believe, this might not be the most efficient way of doing it, is we can unify this predicate and object here with this other triple that says, well, these are the same, and well, what's the subject of these things, and so this might bind properly. So I'll go ahead and do that. Also, feel free to give me suggestions on how we might do that, but I want to get this recording done. So let's see if we do that, and we go ahead and go through our process of dumping out and reloading things and printing this out. Maybe we'll get something a bit better for countries. Okay, yeah, it looks like we got something a bit better. So here we have Chile and yeah, type country, and Greece of type country, Peru. So this looks like it's a little bit better. We still have this odd null ID. So there's a bit room for improvement here, but I don't want to spend too much time on it because in the next lesson we'll learn a way of using a standardized JSON LD processor using the PyLD library in order to do this whole transformation without having to make these custom JSON encoders. I guess what I'm saying is the way of transforming an RDF representation in triple format and triples to JSON linked data has been standardized, and that's what we'll be doing next time. And we'll see how we can use that output and input it into a Mongo database and get querying from it using a document-oriented way.